Section 12.2, Problem 11. A recent study examined the effects of carbon monoxide exposure on a group of construction workers. The following table presents the number of workers who reported various symptoms along with the shift. So we have the table below. It shows the shift morning, evening, nighttime, and we have the symptoms like influenza, headache, weakness, shortness of breath. So the question asks us A, B, C, D. If you do D, that means you already involved the A, B, C. So I will just do the part D and I will explain the A, B, C. Okay, so for this problem, we want to find we want to check the hypothesis testing for independence. So that is the keyword. Under the null, we always put independent. So what does it mean by independent? It is the shift and the symptoms are independent. We always put independent in the null. And alternate for this would be dependent. Step number 2, the test statistic and the critical value. Step number 3, the critical value. So test statistic, we will get it from the GeoGebra. So we go ahead and go to the GeoGebra. And then you click on statistic. The last one you will choose chi-square test. So this is the independent test. So we have 3 shifts. So that is the shift will be the column. So we have 3 columns. We have 4 symptoms. So that is the rows. For the blue shaded, you can put out the name like morning, evening, night, and influenza, headache, and so on. But if you don't want to put those name, the categories, then that's fine. Okay, so go ahead and put down a number in here. So we have 24, we have 33 here, 6, 11, 16, 5, 7, 9, and 9. Okay, so the degree of freedom is 6, and the chi-square is 17.57. That is the chi-statistic. 17.57. The degree of freedom is 6. So we already answer right here, degree of freedom. So that is 6, right? Degree of freedom. And the chi-statistic is part B. So this is part B right here. And this is part C. Computer test frequency, I will show you. Expected frequency, I will show you later. Right here, if you want to get the expected frequency, in the GeoGebra, you can see the word said expected count. We just go ahead and click on it. Okay, then we will get this. And if you want to be curious, just click on the other thing to see what happened. Yeah. Okay, so we have this is the chi-square contribution, and it's calculate the but we don't need to know this. Okay, to answer the question we only need to get the expected count. For the test you don't have to worry about this, right? Okay, so in the GeoGebra it's give you the P is 0.0074, but in your book they don't do the P value, they only do the critical value. Okay, so we have the critical value is always the right side, and we use the chi. Okay, So 0.05 is the alpha, and we need to get this point. We use the degree of freedom is 6. Degree of freedom is 6 is the right side, and 0.05. So then we got 12.6, about 12.6. Okay, so the test statistic is 17. It land on the shaded, and that is the reject null region. Okay, so when you reject the null, it's land on reject null region. That means we remove this. We reject this. That means we remove this. The independent is gone, so we have dependent. So it means that the symptoms and the shift are dependent.